Chapter 6, Sample Problem Number 7. A 100 Newton box is at initial rest on a rough horizontal surface. The coefficient of static friction is 0.6, and the coefficient of kinetic friction is 0.4. A constant 35 Newton horizontal force to the right is applied to the box. 4 students are discussing the frictional force exerted on the box by the rough surface 1 second after the force is first applied. So rather than go through their statements, our first thing is maybe just draw our free body diagram and see what's going on. So here's our box, and we know, of course, that there's going to be a weight, and there's going to be a normal. There is the applied force, which I'm going to call F sub P, that's 35 newtons, and there's a frictional force which resists it, which we don't know yet. So our first thing is to see whether the box would move under a 35 Newton force. So it would not move if, for instance, the frictional force that we need is to keep it still is less than the maximum. So the maximum frictional force for a static case is mu s Fn. We know that we're given 0.6 as our mu s, and Fn will be the 100 newtons because Fn will exactly balance the gravity since they're the only vertical forces. So that says that the maximum frictional force in the static case is 60 newtons. And since we have 35 newtons, which is less than that, then our frictional force is less than the frictional force that is maximum, so we're okay. The box stays at rest. And the frictional force is 35 newtons. So now we're going to see which of these works in our thing. So Al says the frictional force is 60 newtons, but we just said no, the frictional force is actually 35 newtons. The maximum was 60 newtons. Brianna says the frictional force is 40 newtons. That's also incorrect because that would be the kinetic friction if it were sliding would be 40 newtons, but it isn't sliding yet because it was, as they said here, it was initially at rest. So the 35 is insufficient to get it moving. Carlos says the frictional force is 35 newtons since the box will not be moving, and the frictional force will cancel out the applied force of 35 newton. And that turns out to be consistent with what we found. And then David says it is 40 newtons for the kinetic frictional force and 60 for the static. And what we get here is that he is correct for the kinetic frictional force, although it's not sliding, so there isn't a kinetic frictional force. But he's incorrect for this because, again, 60 newtons is the maximum value. It can be anywhere between 0 and 60. So we find that ultimately the only one who's really correct the whole way is Carlos.